The influence of the moon on our planet is many and very important. Early moon, that is, when the moon was just formed, it was very close to our planet. At that time, the gravitational influence of the moon on our planet was very strong. According to calculations, in the beginning, the moon was 10 times closer to our planet than it is now, that is, it was on average 40,000 kilometers away. It is believed that 4 billion years ago, 1 day of our planet was equal to 6 hours. Due to the strong gravitational influence of the very close moon, the rotation of our planet began to slow down. When the moon is close to our planet, the speed of rotation of the planet around its axis has slowed down rapidly. This means that as a huge body like the moon moves away from our planet, its gravitational influence also weakens. 4 billion years ago, the surface of our planet was completely covered by water, that is, the surface of our planet was covered by only one ocean, there was no land area. At that time, due to the strong gravitational influence of the moon, the waves in the oceans, which covered the surface of our planet, reached a height of 7 kilometers. Current advanced laser ranging technologies show that the moon is moving away by 5 centimeters every year. The moon is expanding its orbit at an acute angle. It is moving away from us by 4 millimeters during each rotation of its orbit, and the gravitational influence of the moon on our planet is decreasing. The gravitational influence of the moon on our planet is very important because our planet's climate, ocean currents, and many other factors depend on the moon's gravity. The rise or fall of ocean and sea waters depends on the moon's gravity, and many important events take place in these processes. For example, when water rises, the territory of aquatic creatures expands. This process somewhat alleviates the problem of nutrition. As the water returns, it releases nutrient-rich minerals and other important chemical compounds from the soil into the ocean and seawater. The power of these necessary minerals is very important for aquatic plants. Of course, the situation 4 billion years ago was very different from our current situation. For example, the early moon, when the moon was just formed, was 10 times larger than its current apparent diameter because it was so close to our planet. To put this into perspective, the average distance of the moon from our planet now is 385,000 kilometers, and the early moon was 40,000 kilometers from our planet. Because of this process, solar eclipses occurred frequently. In addition, the moon's close proximity to our planet means that the length of its orbit was 10 times shorter than its current orbit. Currently, the time for the moon to complete its orbit is about 1 month, and if the distance of the orbit is 10 times shorter, the moon's rotation around our planet will be much faster. Due to the small distance of the orbit, the distance between the moon's ascension and declination angle was much shorter than now, so it was forced to stay between the sun and our planet more often. During today's solar eclipse, the total lunar eclipse shadow will be no more than 300 kilometers wide. During a solar eclipse 4 billion years ago, the moon's total shadow was likely more than 1,000 kilometers wide, and the process was much more dramatic than the eclipses that occur today. Currently, there are between 2 and 5 solar eclipses per year, and most of these are partial eclipses. A total solar eclipse is rare. 4 billion years ago, solar eclipses occurred every time the moon orbited our planet, and most were total. The reason for this is that the moon was very close to our planet at that time. 4 billion years ago, the climate of our planet was very brutal and dangerous. Due to the rapid rotation of our planet and the gravity of the moon, very strong winds blew until the active rotation impulse of our planet pushed the moon away to the required distance, and as a result, a calm atmosphere was formed on our planet, and it took a lot of time for these processes to occur. According to some concepts, the connection of the moon to the vital processes taking place on our planet began even before the appearance of the moon itself. According to this hypothesis, as a result of the impact of Theia on our planet was slightly overturned, that is, it forced the poles of our planet to tilt by 23.5 degrees. As a result of this, our planet began to change seasons. At this time, the moon itself has not yet fully formed. Without phase shift, it would be very difficult for life on our planet. Because abundance on our planet has a lot to do with the changing of the seasons. At this point, the question arises why the moon, which has an atmosphere and life on our planet, does not have both. Because life depends on water and air, neither of which the moon has. Water on the moon is only in the form of ice, and there is very little, and there are craters and underground that do not get sunlight. Water for the tricycle for life must be in liquid form. In order for water to be liquid on the moon must have an atmosphere. We know that the moon has no atmosphere. This is because the gravitational force of a small space body like the moon is not enough to hold the atmosphere. It would take at least the weight of Saturn's moon, Titan, to maintain an atmosphere. Our moon is much lighter than titanium, so it has no atmosphere. Since there is no atmosphere, water evaporated by the heat of sunlight does not fall back to the surface of the moon. Therefore, water on the moon is crystalline, that is, only in the state of ice. In its frozen state, it can only be found in protected, cold temperature areas. The places where water ice on the moon resides are the shadows of the craters and the subsurface, where any ice remaining on the surface of the moon has already evaporated in the heat of sunlight. Another reason why a small space body like the moon cannot retain its own atmosphere is its proximity to the sun. Because the solar wind sweeps the atmosphere of bodies with weak gravity. The moon has only a very weak exosphere. The moon's exosphere is so weak that it cannot hold water vapor at all, nor does it have the power to protect against meteorites. Another reason the moon lacks protection from the solar wind is that the moon has no magnetic field. Once upon a time, when the inside of the moon was in a liquid state, that is, when the core was not yet crystallized, it had a magnetic field. But now the moon's magnetic field has disappeared. Therefore, solar radiation falls on the surface of the moon without any resistance. Due to this process, helium-3 gas, in other words tritium, is abundant in lunar soils. The reason our planet is low in tritium is because our planet's magnetic shield prevents solar radiation from reaching the Earth's surface. The main source of tritium is solar radiation. Only one thing is known about the contribution of the moon to the development of life on our planet. We can never calculate how much the moon has contributed to life on our planet.